So let's start the presentation. Firstly, I want to explain the introduction of mini project. The keypad controls 7-segment display with PIC 18F458 is the name of our small project. This project builds a basic interactive system using a PIC 18F458 microcontroller, a keypad, a 7-segment display, and a push button. The 7-segment display shows the matching number that the microcontroller reads from the keyboard. A reset function is provided by a push button. The source code for the circuit is developed in Proteus with keypad input and display output handling in mind. So, the objective we can get from our mini project is, at the end of this project, students should be able to design a schematic circuit using Proteus. Second, establish connection between the keypad, 7-segment display, push button, and PIC 18F458 microcontroller as per the provided requirement. Third, configure the keypad as an input device for user interaction with the system. And fourth, develop firmware code to detect keypad inputs. And finally, initialize and configure the microcontroller peripherals to effectively interface with the keypad and 7-segment display. Next, let's discuss about the instrument. The instrument is create a small project with a PIC 18F458 microcontroller, keypad, push button, and 7-segment display. The input from the keypad is read by the microcontroller, which then show it on the 7-segment display. The reset feature of the push button is utilized. The project's source code and appropriate schematic circuit are implemented in Proteus. Next, I want to explain about the theory. The theory is a PIC 18F458 microcontroller, a keypad, a 7-segment display, and a push button make up the circuit. With a resistor linked to the PIC, the push button serves as a reset button. The 7-segment display is the output and the keypad is the input. When the code recognizes keyboard input, the 7-segment display shows the relevant number. To design this mini project, the PIC must first be connected to the components. Port B to the 7-segment display, port D to the keypad, and a pin must be assigned for the push button in order to construct this circuit. Put a pull-up resistor in between the VCC and the push button. To enable reset capability, attach the push button to a pin on the PIC, connect rows and the columns to port D, and set the appropriate pull-up resistor for the keypad. Initialize port D as the keypad's input, port B as the 7-segment display output, and set the push buttons pin to reset in the code. Continually scan the keypad and show the corresponding value on the 7-segment display when a key is pressed. Reset the PIC if the push button pressed. Finally, simulate the circuit in Proteus, ensuring proper connection and functionality, and save the schematic. In the code, implement a procedure to read keypad inputs and display them on the 7-segment display, along with a reset function triggered by the push button. As you can see in the project design schematic, the PIC microcontroller, which is the core of the control system, is connected to the other components in a precise manner thanks to the project schematic diagram. The microcontroller functions as the main processing unit and communicate easily with a keypad to receive input signal and a 7-segment display to display output. The input data transmission is made possible by the complex connection of the keypad's columns to port A and its row to port B of the microcontroller. Port C is used to carry output signals intended for numerical display, which light up the 7-segment display and gives succinct and clear visual feedback. Additionally, the software reset feature strengthens the system dependability by providing a fail-safe mechanism by using the monitor timer to detect possible system reset. This carefully thought out design guarantees reliable functioning. In addition, logical connection enabling a control system powered by the PIC microcontroller to perform flawlessly. Next, I will explain about the source code. This source code is for interfacing a keypad and a 7-segment display with a microcontroller designed to run on Proteus simulation environment. It's begun by setting up the pin configurations for the keypad and the 7-segment display. The keypad is connected to port B, 4 reading rows, and port A, 4 setting columns. Port C is used for driving the 7-segment display. Internal pull-ups for RB4, RB7 are activated to ensure stable readings. Inside the endless loop, it sequentially scans through each column of the keypad. When a button press is detected, it checks the corresponding row and displays the appropriate digit on the 7-segment display. If special button like star and hashtag is pressed, it can execute specific action which are yet to be implemented. Additionally, there's a software reset function that enables the watchdog timer and enters an infinite loop, effectively causing a software reset. To simulate this in Proteus, you set up the microcontroller and model and connect the pins accordingly for the keypad and 7-segment display. You simulate button presses on the keypad to see the corresponding digit displayed on the 7-segment display. You might also want to add implementation for the special button like star and hashtag. Finally, you can test the software reset function by triggering it and observing the behavior of the microcontroller in response. Overall, this code provides a basic framework for a keypad-based interface and can be further expanded for more complex applications.
Okay, now let's see before and after simulation of our project. We will walk through the functionality of our circuit. Our circuit features a PIC 18F458 microcontroller interface with a keypad and a 7-segment display. The goal is to input numbers from the keypad and display them on the 7-segment display. In the initial simulation, there is no output on 7-segment display because there is no input from keypad. Let's see the after simulation process. Pressing 1 on the keypad, display 1 on the segment display. Similarly, pressing 2, display 2, and so on for number 3 through 9 as well as 0. Notably, pressing hashtag or star on the keypad result is no output on the 7-segment display, maintaining clear display. Additionally, we have introduced a reset button to the circuit. This button allows user to reset the simulation, providing a seamless user experience and facilitating testing and debugging process. Let's see the discussion of our mini project. Our mini project is about creating a circuit using PIC 18F458 microcontroller, a 7-segment display, a keypad, and a push button. A PIC 18F458 microcontroller is like the brain of our circuit. It takes the input from the keypad and shows the output on the 7 display. We use the push button to reset the microcontroller if needed, and we include a resistor to keep the voltage stable. The keypad is how we interact with the circuit, and each key press sends a signal to the microcontroller. Depending on the key press, the microcontroller tells the 7-segment display what number to show. This project helps students learn about digital electronics and how to build systems that take input and show input. In conclusion, our project exemplifies the seamless integration of a PIC microcontroller with various input and output devices. The push button serves as a reliable reset function, ensuring the microcontroller starts in the known state, while the pull-up resistor prevents floating input for stable operation. Introducing a keypad as an input interface, user can input values to the microcontroller with a 7-segment display accurately reflecting the user input. This demonstration highlights the effectiveness of interfacing different components with the microcontroller, enabling versatile input and output functionalities in a digital system. From an educational standpoint, this project offers valuable hands-on experience in digital electronics and microcontroller programming, fostering a deeper understanding of component interfacing and system design principle. Let's take a look at the reference used in our project. The first reference of our project is Practical Work 6. Second one reference to is from Microcontroller Lab by Mr. Lab, published on April 12, 22. It provides insight into 7-segment interfacing with the PIC microcontroller. The third one is from Circuit Digest, offering information on 7-segment display interfacing with PIC microcontroller. Reference 4 is a YouTube video by SS posted on December. Interfacing on 7-segment display with 8051 microcontroller. Reference 5 is a presentation hosted on Script. It offers insight to mini project that implement our topic. These references have been invaluable in shaping our project, providing diverse perspective and insight. Okay, that's all from us. Thank you.